Okay, good day mga kapatid. So welcome to our General Physics 2 class. And today, we are going to discuss more on capacitors, specifically circuit geometry, capacitors in series and parallel. Okay, so we are going to discuss further on this learning competency, specifically competency number 2 and number 3. Okay, but before we proceed with our main topic, let us recall what we have discussed on our previous lecture. Okay, so as we know, capacitor is a device or an electronic device that could store electrical potential energy and electric charge. Okay, it is composed of two conducting plates with separated with an insulating material, okay, which we call as a dielectric. Okay, so the measurement of how much energy a capacitor could store is in terms of capacitance. Okay, it is given the equation C is equals to Q over V, where C is our capacitance, Q is the magnitude of the charge, and V is the magnitude of our electric potential. Okay, rearranging the formula, okay, pwede rin po natin gamitin yung equation na Q is equals to C times V. Okay, in terms of capacitor with different types of dielectric, mathematically, okay, we use the expression C is equals to epsilon naught multiplied by A divided by D, okay, where epsilon naught is our permittivity of free space, which is equals to 8.85 times 10 raised to negative 12. Area is our plate area, and D is the distance between our plates, okay? So, if ever na meron po tayong relationship with or there is an effect of the dielectric used because capacitor depends on its construction, so we have to multiply this expression to the K, okay? Or the dielectric constant. The dielectric constant is equals to the constant of that specific material, okay? Because we have different types of capacitor, for example, an electrolytic, mica, ceramic, paper, and etc. Okay? So, pwede rin po natin gamitin yung equation if ever na nagkaroon po tayo ng effect of dielectric constant na Ck is equals to C naught multiplied by K. Or, pag voltage naman yung hinahanap natin, V naught over K. Okay? So, now, okay, na nakapag-recall na tayo, magagamit po natin itong tatlong formulas na to and this other formulas in order for us to fully understand circuit geometry, capacitors in circuit and series and parallel. Okay, so but first, let us define what circuit geometry is. Okay, so electric circuit or electrical network is described as the path for transmitting electric current. An electric circuit or electronic circuit includes devices that gives energy to the charged particles constituting the current. Okay? So we use various components. Okay? So to analyze a circuit or an electrical network. Okay? So gumagawa po tayo or nag-illustrate po tayo ng schematic diagram. Okay? Yung ating mga different components, for example, resistor, transistor, diode, a lamp, a voltage source, and so much more. Kaya magamit po tayo dyan ng representation. So, VCC or basta power supply, okay, ginagamit po natin yung pong plus negative or plus minus pag power supply. Kapag ka naman po ganito, okay, so this part is an example of a polarized capacitor. This is an inductor, this is a non-polarized capacitor, this is a type of diode, this is a resistor, this is type of load, pwede rin po siyang capacitor, and so much more. Okay, pero magfo-focus lang po tayo dito sa tatlo, okay, capacitor, resistor, and our voltage source. So, yun po yung madalas nating makikita. Okay, ito rin po, ginagamit rin po natin to, okay, to represent symbol for voltage supply. Okay, so pero sa capacitor po, ito po yung gagamitan natin. Okay, para di po tayo malito kung polarized or non, let's use a general, okay, classification of capacitor, which is a non-polarized capacitor. Okay, so sa circuit geometry, mahati po yun sa dalawang types. Okay, series circuit at saka parallel circuit. Okay, what could you see the difference between a series circuit and parallel circuit? Okay, so pag series circuit, yan, so connected po sila lahat sa isang volts. So makikita natin dito sa parallel circuit, it is divided into nodes. Okay? So for example, meron tayong mga loads, okay? Meron po tayong mga components connected in these two types of circuit. Okay? For example, a light bulb. So what could you see, okay, in this uh, illustration or animation? So ano yung nangyayari kapag series, tsaka ano yung nangyayari kapag parallel? Kung tinanggal natin yung isa sa loads natin, okay? For this example, a light bulb. Okay? Balikan, dito muna po tayo kay series. So makikita natin, okay, ito yung load supply natin, yung voltage supply. This is our lamp 1. Okay? This is our lamp 2. And this is our lamp 3. Okay? Inalis mo si lamp 3, tinanggal mo siya dun sa connection. Okay? So, ang nangyari, hindi na po umilaw si lamp 1 tsaka si lamp 2. Bakit po nangyari yon? Kasi, in series circuit, okay, they share the same current. Okay? So, meaning, kung ano yung current na dumadaloy sa lamp 1, lamp 2, and lamp 3, yun po rin po yung dumadaloy dun sa lahat ng components ng system na yon. Okay? So, kung ano yung total, okay, kung ano yung total current dito sa supply natin, sa power supply natin, equal po siya sa current na dumaan sa sa 1, na dumaan sa 2, at saka dumaan sa 3. Okay? So, current, directly proportional po yan sa charges, sa dami ng charges na meron dun sa load na yon. So, QT, or total charge, is equals to charge sa load 1, charge sa load 2, at saka charge sa load 3. Okay? Kung voltage naman po yung pag-uusapan natin, okay, yung voltage VT, okay, dito na po tayo nagkakaroon ng paghahati, okay, paghahati ng voltage dito sa ating system. So, para makuha po natin yung total voltage na sinupply po ng ating source, okay, we have to get the total voltage drop or voltage dissipation, yung makukuha po nating voltage doon sa ating individual loads para makuha po natin yung voltage supply. Kasi kapag series circuit, okay, nahahati po yung voltage. So if ever na connected ang mga circuit or mga components nyo in a series circuit, so mapapansin nyo, okay, kung ano yung pinakamalapit sa positive, yun po yung may pinakamalinaw, okay, malinaw na ilaw. Okay, hindi lang masyadong mapapansin dito sa animation. Okay, that is due to the voltage is dropping. Okay, so mas nag-consume to ng voltage, so konti na lang yung matitira. Kay V2, konti na lang din yung matitira kay V3. So si V3 yung may pinakamaliit na voltage dissipation. So if we are going to add them up individually, so makakalculate po natin yung total voltage. Okay? So now let's move on dito sa parallel circuit. Okay? Ano yung napapansin natin? Ano yung observation natin? So kapag inalis natin yung isa, okay, this is lamp 1, this is lamp 2, this is lamp 3. So kapag inalis natin yung isa, okay, nailaw pa rin si lamp 3 or nilis natin si lamp 2, meron pa ring effect or meron pa ring nadaloy kay lamp 3. Dahil po yan, okay, hindi po natitigil yung supply ng current at saka hindi rin po natitigil yung supply ng voltage. Kasi kapag parallel po ang circuit natin, yung total voltage mo, okay, yung total voltage mo sa supply mo is equal sa lahat ng voltage doon sa loads mo. Okay? So kaya kahit natanggalin mo yung connection kay lamp 2, iilaw pa rin si lamp 3. Also, kung titingnan mo yan in reality, okay, katulad po nung ating mga Christmas lights, mapundi man yung isa, na ilaw pa din yung kadugtong kasi they are connected in parallel. Okay? At pantay-pantay din po yung amount or luminance nung pag-ilaw nila. Okay? So, kabaliktaran po kay parallel circuit, dito, nahahati yung current natin. So, kunwari dito yung IT. Okay? So, kapag nakakita po siya ng nodes, this is an example of nodes, yung mga kantuhan, okay, para siyang hole, okay, para siyang hole na tinitreat po siya as hole or butas ng ating current. So, mahahati po, magkakaroon ng flow dito, magkakaroon ng flow dito, okay? Magkakaroon ng flow dito, tapos dito, yan, so and so on, if ever na meron pa tayong mga connected na loads, okay? So, meaning, okay, yung IT natin, or yung total current natin would not be the same in each component. Okay, so kapag parallel, IT is equals to current sa 1 plus current sa 2 plus current sa 3. Okay? So, since current is directly proportional with our charges, so yung charges natin, QT is equals to Q1 plus Q2 plus Q3. Okay? So, tandaan po natin itong concept na to. Okay, so capacitors is a component. So, it can be connected in either series or parallel. Okay? So, capacitors in parallel. So, kunwari meron tayong, just like this one, meron tayong load with 3 capacitance or 3 times capacitance. Okay? Wala po siyang pinagkaiba kung ganito po yung magiging connection niya. Kasi when capacitors are connected in parallel, the total capacitance of is the sum of the individual capacitors. The general equation for capacitors in parallel is C1 plus C2 plus C3 and so on. So, kapag po ang capacitors po natin ay connected in parallel, we have to simply add the magnitude per each capacitance ng ating capacitor. Okay? So, for example, yan, meron po tayong C2 and C3. So, ang value po niyan nila ay 100 microfarad and 200 microfarad respectively. So, if we're going to calculate the total capacitance of these two components, so i-add lang po natin si C1 plus C2. So, 100 microfarad plus 200 microfarad. So, CT is equals to 300 microfarad. So, kung kukunin po natin yung V2 or voltage at capacitor 2 at saka voltage at capacitor 3, so since base po dun sa na-discuss natin na VT, okay, VT is equals to the voltage at the load. So, pareho po yung value niya kapag connected po siya sa parallel. So, yung value po ng V1 at V3 natin, okay, V2 at V3 natin would be equal to 10 volts. So, kapag charge naman yung pag-uusapan, okay, so QT, sabi natin is equals to Q1 plus Q2. Okay, since wala pa po tayo na-compute na total charge dito sa system na to, so compute muna natin siya. QT is equals to CT saka VT. Okay, so yung CT natin, na-compute natin, 300 microfarad multiply by 10 volts. Okay, QT is equals to 0.003 or 300 times 10, hindi, 0.003 na lang. Hindi kayo malito. 0.003 coulombs. Okay? So, ito yung QT natin. So, pwede nating makuha yung kung kukunin natin yung individual charge sa Q2 tsaka Q1, okay? So, mag-start tayo kay Q3 pala to, 3. Okay, Q2 is equals to C2V2. So, ang C2 natin is 100 microfarad. Ang V2 natin is 10 volts. Okay, so equal po siya sa 0.001 coulomb. Tapos, ang Q3 natin ay C3 V3. Okay, so 200 microfarad multiplied by 10 volt is equals to 0.002 coulomb. So, kung i-check po natin yan, dun sa value na nakuha nating total charges, so kailangan Pag pinagsampu natin sila, equal po sila sa 0.003 coulomb. Okay, so tama po yung ating ginawa. Okay, so tandaan po, pag capacitors is parallel, the voltage from the source, okay, from our source, or yung pinakamalapit na voltage sa kanila, na connected sa kanila, ay equal po doon sa individual voltage per each capacitor. Okay? So kapag ka naman po, in terms of charge, kung ano yung total, okay, ano yung total charge doon sa source, so yun po ay due to the sum of the individual charges per each load. Okay, for this example, yung QT natin at this source, okay, is equals to Q1 and Q2. Okay, so yun po. Okay, next, capacitors could be also connected in series orientation. So when capacitors are connected in series, the total capacitance is smaller, okay, than the smallest one. The general equation for capacitors in series are just like this one. So CT is equals to 1 over 1 over C1 plus 1 over C2 plus 1 over C3 and so on. Or pwede po nating itong expression na to raised to -1. Okay? So kapag meron po tayong dalawang capacitors, pwede po natin gamitin yung product over sum rule. Okay? Ito po ay applicable lang kapag dalawa. Okay? Dalawang capacitors in series. Okay? So we could get the total capacitance of two capacitors, okay, using C1 multiplied by C2 over C1 plus C2. So this is product, okay, product over sum rule. Okay, so let's try, okay, this one. So we have here three capacitors connected in parallel. So we are going to compute the total capacitance of the system. So sabi natin 1 over C1 plus 1 over C2 plus 1 over C3 raised to -1 is our equation for total capacitance in series. So 1 over 2 farad, okay, plus 1 over 3 farad plus 1 over 5 farad raised to -1. So total capacitance is equal to 0.9677, okay? 0.9677 farad. Okay? So may concept po tayo regarding capacitors in series. So, if we are going to calculate the individual charges, okay, the individual charges per each load, Q1, Q2, Q3, okay? So, QT is, kung ano yung charge natin sa source, equal po siya sa charge ng lahat ng ating capacitors. Okay? Kasi po ay connected po siya into series. Okay? So, Q4, para hindi tayo malito, Q4, Q5, and Q6. Is equals to Q5 is equals to Q6. Kapag voltage naman, okay, kapag voltage, okay, we are going to get the individual voltages and in terms of the total voltages, so it is the sum of the individual voltage dissipation or voltage measurement in each load. Okay, equal po siya sa V4 plus V5 plus V6. Okay, since given po tayo ng CT, okay, alam naman po natin yung QT ay equal sa, compute muna pala natin yung QT. Okay, QT is equals to CT/VT. Okay, ang CT natin is 0.9677 farad multiply by 50 volts. Okay, our QT is equals to 48.39 coulomb. Okay, so this is equals to 48.39 coulomb. Okay, so pwede na po nating ma-compute yung V. Okay, kasi alam naman po natin yung capacitance and the individual charge number. Okay, so start po tayo kay V4. So V4 is equals to Q4C4. So equal po siya sa 48.39 coulomb divided by 2 farad. Okay. Tapos same process po with V5 and V6. Q5 over C5 plus V6 is Q6 over C6. Okay, this 48.39 coulomb divided by 3 farads. Okay, same. 48.39 coulomb divided by 5 farad. Okay, si V4 equal po siya sa 24.2 volts. Tapos, si V2 equal po siya sa 16.1 volts. And then si V6 is equals to 9.7 volts. So, if ever gusto po nating i-recheck yung ating answers, so the sum of all this voltage rating per each load should be equal to 50. Okay? So, 50 is equals to 24. Checking. Okay, 24.2 plus 16.1 plus 9.7. Okay, it is equals approximately to 49.999,998. So, tama po ang ating ginawa. So, medyo iba lang siya kasi nag-ground off. Okay? So, that is how we solve the total capacitance per series and parallel circuit. Okay? And to calculate individual charges and voltage per each load connected in series and parallel. So if you ever have questions or queries regarding this lecture, do not hesitate to message me. So that would be all for this day. So again, goodbye and thank you.